Unit 2, Section 4. Section 4, Axioms of Probability. By the end of this session, we should be able to state at least 3 axioms of probability, explain at least 3 of them, and apply at least the 3 axioms to calculate probability. Let's set the ball rolling. When we talk about axioms of probability, what does it mean? These are some, or let's put it this way, there are some basic rules that guide and facilitate calculations involving probability. So these rules are often noted as axioms, and they describe properties of a probability measurement. So you got the point. Yes, these rules are often noted as what? Axioms. These are the basic rules that guide us and facilitate our calculation in probability. So look at a couple of axioms, about 5 of them. Axiom 1. If an event E is a sure event, then the probability of E is 1. If the event is sure, the probability is 1. Can you think of any event that, yes, sure, it will be 1? You can think about that yourself. Axiom 2. If an event E is an impossible event, then the probability of E equal to 0. The probability is not possible. Yes, it's also an impossible event. Can you think of any example? I mean that you have a lot to think about, right? Give an example to yourself. Try it yourself, right? Try. Axiom 3. For every event, let's say event E, 0 is less than probability of E less than 1. Or let's put it this way, 0 is less or equal to probability of E and less or equal to 1. What it means is that probability of any event ranges between 0 and 1. So what it means is that probability cannot be less than 0, neither will it be more than 1. And what are the numbers between 0 and 1? Do you know them? Well, they are proper fractions, right? You got it right. Proper fractions. So if its probability is 0, that event is impossible. If it is 1, that is sure events. Axiom 4. Suppose that E is any event of a sample space of an experiment. If E prime, you see the E prime we talked about earlier, if E prime, as highlighted here, is a complement of the event E, then a probability of E plus its complement gives us 1. Yes, probability of event and its complement should give us 1. So let's set an example of this. Let's say the probability of a seed planted, the probability of it germinating is 0.7. Then what would be its prime or its complement? Then its complement will be 0.3, because 0.7 plus 0.3 should give you 1. And it's even easier to get the complement when you know the probability is. For instance, when you make a change of subjects, the complement of probability will be equal to probability, the complement of it will be equal to 1 minus the probability of E itself. You get it? Yes. So if you know one of them, by the use of this equation, you can get the other one. Axiom 5. For any event E and F, probability of either E or F or both, that is probability of E union F, equals to probability of E plus probability of F minus the intersection of the two, probability of E intersection F. Well, let's try an example. Example 1. Find the probability of obtaining a prime or an odd number if a fair die is tossed once. Of course, we are familiar with a fair die. The sample space will be 1, 2, 3, up to 6, giving us the number to be 6. Now we're talking about the observation is a prime or an odd number. Now let's look at the prime numbers in that set. So the prime numbers will be 2, 3, and 5. So let B be the odd numbers, that is 1, 3, and 5. Now you realize that there can be a number, or there is a number that appears in both sets. That is a set of prime numbers and a set of odd numbers. What number is that? What numbers are that? You could see that's 3 and 5. So that is the intersection of the two sets. The set A being the prime numbers and set B being the odd numbers. So a prime or an odd number simply means prime union odd. So if A is prime and B is odd number, so it could be written as P of A union B, and this is equal to probability of A per the fifth axiom, probability of A plus probability of B minus probability of A intersection B. And you know the values already. Probability of A is 3 out of 6. Probability of B is also 3 out of 6 as 3 elements. And the probability of A intersection B is only 2 elements out of 6. And doing the algebra world, we should have 4 out of 6 that results in 2 out of 3. Very wonderful, right? Thank you very much.